Okay, so today we are going to solve simple radical equations. Open up to page 41 in your packet. And the directions say, use your understanding of inverse operations to determine the solution for each problem. To circle any problems that do not have any real solutions. And we're going to talk about what that means in terms of extraneous solutions as well. So for number one, we need to isolate the x to solve. So the inverse of the square root is to square. And if you do it on the left, you have to do that operation to the right. We get x is 81. You can check it. Anytime you have an even index on a radical, you should check your answer. So if we plug the answer in, is the square root of 81 equal 9? Yes, it works. Okay, so now we're going to do number 2. So before you can do any operation to the radical, you have to isolate that radical first. So to do that, we're going to add 1 to both sides, and we'll get the square root of x equals -3. Then we can square, and we would get x is 9. However, let's check that. When we plug it in, we get 3 minus 1, which is 2. That does not equal the -4 the problem started with. So 9 is not an answer, it's extraneous. So this has no solution. Another way we can think about that is when we had here the square root of x equals -3, we know the domain for the square root function never goes to negative values. The endpoint is at 0, 0, and it increases. So this statement of the square root of x equals -3 is not true, so I could go right to the no solution. Okay, so let's try number 3. Subtract 15 to both sides. And then we can square to eliminate the square root, and we get x is 49. And we should check it. So the square root of 49 plus 15, 7 plus 15, that is 22. It works. Okay, and for number 4, try 4 and 5 in your groups. We'll pause the video here for you to try 4 and 5, and then we'll resume the video for you to check them. Okay, so in 4, the first thing you have to do is subtract 3 to the right. Then we're going to divide by -1. And right at this spot, I'm going to say no solution, because the square root of x will never equal -2. If you didn't realize that and you squared both sides and you get x is 4, when you plug that in, that's a 1. You don't equal the 5 the equation started with, so you would cross out the 4 and write no solution. Okay, and for 5, we have to start by squaring both sides, then divide by 2. We get 18. And if you check that in the equation, it works, so 18 is your solution. Okay, so now 6, 7, and 8, if you notice, they all have cube roots. So the initial process is the same. You have to isolate the cube root. So in 6, we'll get the cube root of x equals 10. And then the inverse of the cube root is to cube, and we get 1,000. And then we would check it back in the original. So the cube root of 1,000 is 10. 10 minus 4 is 6, and that is what we got to start with. So 1,000 is our answer. Okay, you try 7 and 8. We'll pause the video for you to try them, and then we'll resume and check your answers. Okay, in 7, I'm going to subtract 2 to both sides, then cube. So negative 8 times itself 3 times is negative 512. Because your quiz tomorrow is no calculator, if you weren't sure, you could do 8 times 8 is 64, then times 8 again. 8 times 4 is 32. Oops, 32. Carry the 3. 8 times 6 plus 3 gives us the 51, and there's our 512 because it was negative. All 3 were negative. And if you check the cube root of negative 512 plus 2, oops, there's a negative on there, that gives us negative 8 plus 2, which is negative 6. And then lastly, for number 8, first you have to divide both sides by 2. Then we'll cube both sides. Add 1. And we get x is negative 7. And if you check it, it should work. If you think about the domain of the square root function, had a domain of x greater than or equal to 0. But the cube root function, what the domain was, x is all reals. So you're on the square root, because the domain is restricted, you may get extraneous solutions. Whereas with the cube root, because the domain is any x that exists in all real numbers, there will not be any extraneous answers because x can be any real number. Okay, so we're going to keep going on the next page, 9 through 16. We're going to pause the video here for you to try all the problems, do 9 through 16 in your groups, and then we will come back and check. Okay, so in number 9, to eliminate the power of 1/2, we're going to square both sides. We get x is 16. We're going to check it. I know the power of 1/2 is the same thing as the square root, and that equals 4. In 10, I'm going to subtract 9 to the left, and 14 minus 9 is 5. Square both sides, and we get 25 is x. So those are our 16 and 25 are your first numbers. If you check the 25, it does work. It is not extraneous. In 11, we're going to cube both sides. So 4 times 4 times 4 is 64. Then we're going to multiply both sides by 3. And we get x equals 192. Now, if you're not sure about 64 times 3, you can do 60 times 3, which is 180, and 4 times 3, which is 12, and then add them up, and that's how we get 192. So if you break the 64 into its parts of 60 and 4, it makes some of the mental multiplying a little easier. Okay, for 12, you have to square both sides to start. Add 1 to the right. We get x is 50. It is not extraneous. It works when you check it. For 13, we're going to divide both sides by 6. And 54 divided by 6 is 9. Then you're going to square both sides. So 9x equals 81. Divide by 9, and x is 9. Check that back in the original equation, and it is not extraneous, it works. Okay, for 14, first we're going to subtract 7 to the left. We get negative 8 as the square root of 5x minus 1. And right there you can stop. The square root equals a negative value. There is no solution to number 14. If you did keep solving and squared both sides and then finished and isolated the x, and when you checked your answer, you would get a not true statement with the original equation, and you would see that then there is no solution. Okay, in 15, we'll subtract 1. So we get x to the 1/5 equals 1. And then to eliminate the power of 1/5, we'll raise both sides to the 5th power. So we get x is 1, because 1 times itself 5 times is still 1. Because it is an odd denominator, and we know that you could rewrite that as the 5th root of x, so then it's the odd index, there will be no extraneous solutions because the domain is all real numbers. So for 15, you technically don't then have to check it. And last but not least, for 16, I'm going to add 8 to both sides. And I'm going to square to eliminate the square root. And subtract 1. And we get 99 is x. When you check that, so let's go back to the original. We got negative 8 plus the square root of 100. It's negative 8 plus 10, which is 2. That's what we started with. It checks. Okay. This is what I've been saying as far as the even radical versus an odd radical. When we are solving radical equations, we need to be careful not to square a negative number, because when we evaluate a square root, only positive numbers can be produced by that square root. Cube roots can produce not negative numbers, so they don't have extraneous solutions. Odd roots can produce negative numbers, even roots cannot. Therefore, we know we are going to have an extraneous solution when we square a negative number as part of our solving process. For example, if we have the square root of x equals negative 3, like this, there will be no solutions. This works for all even roots. Odd roots are okay because they have a domain of all real numbers. So if you think of the difference between the square root domain and then cube root domain, which was all reals, there's restrictions here with the even radical, so we might have extraneous solutions. We can pause the video here for you to summarize and write this down in a few words in your notes. Okay, your homework tonight is packet page 40. We do have a note for you to skip 13, 14, and 15. Again, you have to show your work, so I recommend separate paper, because when I check it tomorrow, if you have no work, you get no credit.